An investor's retirement account pays annual nominal interest rate of 4.2% convertible monthly. On January 1 of year Y, the investor's account balance was X. The investor then deposited 100 at the end of every quarter. On May 1 of year Y plus 10, the account balance was 1.9x. Determine which of the following is an equation of value that can be used to solve for x. So January 1 of year Y is the starting point, and then May 1 of year Y plus 10 is the end, and this is almost like April 30 of year Y plus 10. By April 30, we have four more months in that last year, the Y plus 10 year. And the deposits are being made at the end of every quarter. So let's look at what's happening here. So first of all, since the deposits are quarterly, we will need the quarterly effective interest rate. Let's call it J. So J is I4 by 4. And we are given that I12 is 0.042 because we're given that it's 4.2% convertible monthly. So that's I12. And the relationship between I4 and I12 is this: 1 plus I4 by 4 power 4 equals 1 plus I12 by 12 power 12. Because both of them are equal to 1 plus I, the main relationship between them is 1 plus I equals 1 plus I m by m power m. And since both of these expressions on the left and the right are equal to 1 plus I, so they are equal to each other. And okay, here we're calling it Q. So 1 plus Q power 4 equals 1 plus 0.042 by 12 power 12. And this whole expression evaluates to 1.0428. And then we take the 4 through it and then subtract 1. So Q comes out to be 0.0105. So that's the quarterly effective rate. Now, we will also need the monthly rate, and that would just be I12 by 12. Let's call it M. And I12 was 0.042, so monthly rate comes out to be 0.042 by 12 equals 0.0035. And now, since the deposits of 100 begin in year Y and are at the end of every quarter, so in 10 years, so the difference between Y and Y plus 10 is 10. So we're talking about 10 years and then a few more months. So the number of deposits made in exactly 10 years will be 10 times 4 because there'll be 4 deposits per year. And so by the start of year Y plus 10, we would have had 10 times 4 is equal to 40 deposits. And one more deposit will be made on April 1. Well, April 1, I said here April 1, but we could also, technically, we should say, since the deposits are being made at the end of every quarter, the quarter ends on March 31. So actually, we can even mention that here. Actually, March 31. Okay, Y plus 10. And that would be the 41st deposit, and there'll be no more deposit till May 1. And so we have 40 at the beginning of year Y plus 10, and then the 41st happens on March 31. The total number of months in 10 years is again 10 times 12 equals 120. And we have another 4 months by May 1, because May 1 is like effectively April 30. And that's 4 months, January, February, March, and April. And so that brings the total months to be 124. So probably over here, we don't even have to say April 1. So we can just straight away. Say one more deposit is made on March 31 of year Y plus 10. But the reason I said April 1 was I was trying to match it to May 1, but there's no need for it. One more deposit is made on March 31. Okay, so number of months we agree is, so here maybe we should say by May 1, it's 10. May 1 is effectively, which is practically the end of April 31. So the end of April 31 is practically the beginning of May 1. So there's no difference really. So 4 months, January, February, March, and full of April. And so before May 1, we have 4 months. So that brings the total months between the start of year Y until May 1 on in year Y plus 10 equals 220 plus 4 equals 124. Okay, so now what we know is that there are 41 total deposits. And if we look at the answer choices, choice A from K is equal to 1 to 42, there are 42 deposits. We don't even have to look at this one. Similarly, choice B from K equals 1 to 42, there are 42 deposits. So we don't even have to look at that one because the deposits are 100. So this term is talking about the deposits, same here. So C is an option because we do have 41 deposits here, and similarly D also has 41 deposits. E is out because once again we have 42 deposits here. So it's either C or D. So if we look at C, remember the account already had X on January 1. And so January 1 of year Y is the beginning of our time. So the account has X on it. And this seems, and then the deposits of 100 start at that point. So the total present value of the account on January 1 would be X plus the present value of the deposit. So we have to investigate this one. And let's see if this this term, this summation term on the left is the present value of the deposits, because then if you add X to it, it becomes the total present value of the account. The account already had an X in it, and then the deposits, let's see if they have this the present value. So so the term here is 100 over 1.0035 power 3K. Now, if we look at the deposits of 100, remember they are quarterly deposits. So the present value of deposits in January 1 and year Y would be 100 over 1.0105. That would be the, remember, these deposits are acting like annuity immediate. So they are happening at the end of the quarter. So the first deposit is pulled back through the interest, the quarterly interest rate, 1.0105. 0.0105 was the quarterly rate as we calculated. Second deposit would be pulled back through 1.0105 squared, right? 1 plus, the first one is pulled back through 1 plus I, second one through 1 plus I whole square. In this case, I is Q, the quarterly rate, since deposits are quarterly, and then we know we have 41 deposits. The last one will be pulled back through 100 over, as would be pulled back through 1.0105 power 41. And then that's because of the pattern. The first one through 1.0105 power 1, second one through 1.0105 power 2. So whichever deposit we are talking about, it's exactly this power that we are having here. So for the 41st deposit, we'll have power 41. And now this isn't quite the summation term on the left-hand side. First of all, we have a different interest rate going on, 1.0035, and also the powers are 3K. Whereas here, if you write it as summation, you would write it as power K, and K going from 1 to 41. However, we notice that this 1.0105 is actually equal to 1.0035 cube, and that you can check on the calculator. So if we replace the 1.0105 by 0.0035 cube in each of these terms, we get the present value in January of deposits on year 1, the present value of deposits on January 1 in year Y. So here I've just replaced each of the 1.0105s by the 1.0035 cube. So the first one is just that cube, second one is that cube square, and so on, that cube 41. And now if you write this one as a summation, it is 100 over 1.0035 power 3k, and k goes from 1 to 41, as you can check. So this was exactly the summation term on the left side of C, this one. And as we discussed earlier, the present value of the account will be the account already had in January 1, which was X, plus the present value of the deposit. So the left side total gives the present value of the account, what we already had plus what was deposited. But we're also told that the account accumulates to 1.9x. The balance is 1.9x at the end, the last date. And now that is the time when we need the monthly, that's the reason why we calculated the number of months, because here we see that the monthly effective rate is being used. Remember, the monthly effective rate, we calculated it out to be 0.0035. So since the balance is 1.9x, 124 months later, remember we already discussed that it's 124 months between the beginning and the end, and the final ending balance is 1.9x. So you pull it back 124 months through the monthly effective rate, and it comes out to be 1.9x divided by 1.0035 power 124, because 0.0035 was the monthly effective rate. And this exactly is what we have on the right-hand side. So C is the correct answer, because we first evaluated the total present value of the account in January 1, and then we pulled back the given balance from the last date onto January 1, and they both should be the same. And that's what choice C is saying. So the correct answer is C,